All right, everyone. I apologize for the delay. Um, could not get the hover cam to work yet again. So I finally got that up and running, and I had prepared for you today um, some questions directly from the no reassignment again. A lot of it is pretty much what we looked at last week, but what I wanted to concentrate on is the numbers that were used so that we were a little bit more comfortable on how we plug them in when we do the practice. So, one of the things that you're going to recognize when we zoom into a lot of these questions is that I'm dealing with a lot with radicals and I'm dealing with decimals or fractions. And again, a lot of that just has to do with um, ultimately looking at how you're going to plug them in the no reassignment. I assure you that I have done all of these questions myself. That way, you know that I'm not just guessing at how it's supposed to be plugged in, that I have in fact done them myself. So we're going to zoom into each of these and we're going to specifically look at our first two here. And first question, I recognize that it's a 30, 60, 90, so I am not going to deviate from what I've always said we should do, which is write our formula around the triangle. So it's the early questions in the no reassignment just ask you to identify which ones are the 30, 60, 90. And then they ask later on, I noticed, if one side is 2A, what's the other going to be? So we're still following our formula. So opposite our 30-degree angle is A. Opposite our 60-degree angle is A radical 3. And opposite our 90-degree angle is 2A. The side that has the formula and the given value, we set equal to each other. So that means everywhere I see an A, I'm going to plug in radical 6. So that means over here, where I see A, we're going to plug in radical 6. And we're going to multiply that by the radical 3 that's already there. And over here, where we see A, we're going to plug in radical 6. Now, what's nice about this is if I'm looking for the hypotenuse, I don't have any extra work to do. The hypotenuse is now going to be 2 radical 6. And we're finished because there is nothing else to simplify. However, on this side, if I was to multiply together that radical 6 and the radical 3, I find out x, the radical 6 and the radical 3, that's going to end up being the square root of 18. Now, if you plug in the square root of 18 as your answer, it's going to be wrong. And that's because it can be simplified. So when we go back and we look at how do we simplify, we look for the biggest perfect square, which is 9, times 2 is 18. So we need to make sure that we simplify that. We don't just pretend it doesn't exist. So we need to simplify. And the square root of 9 is 3, and then we have our radical 2. So it shows up like that because we've simplified. So make sure, depending upon, and I took this question right off of the no reassignment, so make sure that you're accessing those buttons accordingly. Now, it could have been that they asked for the hypotenuse, and it's a very quick answer. It could have been that they're assuming that you know how to do the radicals and that you can plug that in. So this, again, is a no reassignment. Took it right off. Make sure that as you're working things through, use your own paper. Make sure that you simplify accordingly. So let's then go to the next one. Same idea, makes this easy because our formula, opposite the 30 is A, opposite the 60 is A radical 3, opposite the 90 is 2a. We are going to circle the side that has the formula and the given value, and that is set equal. No extra work needs to be done. So I need to remember that I'm going to plug in our 5 radical 21 for A, and we still have our radical 3. And I'm going to plug in our 5 radical 21 over here. When we multiply like terms up here, 5 times 2 is going to give us 10 and a radical 21. Now remember, 21 is only 3 times 7. Well, they're both prime numbers. So that's not going to simplify any further. So our answer for that, for the hypotenuse, is 10 radical 21. Over here, when I multiply these together, I end up with 5 radical 63. Now 63 isn't a perfect square, but a perfect square factor does exist. So when we look at this, if I took 63 and I divided it by the 3 there, we know it's going to be 3 times 21. Hopefully we remember that 21 was 7 times 3. Well, 3 and 3, if I divide 63 by 9, you can see where that 7 shows back up. So when we break this down and simplify, we have to make sure that we bring down our 5, but this is now going to be 9 times 7. So that radical 9 times 7. When we bring down our 5, 5 times 3, and then our radical 7. So our final answer for y is 21 radical 7. Again, looks very different from what we started with, considering the 21, we had a radical 21. All the way through this, we end up with a radical 7. So again, the work itself with the special rights isn't what we're concerned with. It's making sure that we're following our radicals. All right, if you have questions, please make sure that you do chime in the chat. We're going to move over here. Now I did this one specifically with the answer to make sure that there wasn't anything that I was missing. Same setup. We're going to write our formula around. Opposite the 30 is A. Opposite the 60 is A radical 3. Opposite the 90 is 2A. First step is done. We take our formula and the given length, and we're going to set those equal to each other. So 2A is going to be 12.5. When we divide both sides by 2, and here's where I wanted to test it myself, because 12.5, when we divide by 2, is going to get us 6.25. So that means this side is 6.25, because that's the side with just A, matches that. And over here, we're going to plug in 6.25 with our radical 3. Nothing to do here, so this is 6.25 radical 3. Now, I did this problem because I have been so much stressing that you need to make sure you use fractions and you use the fraction access button in NORI and make sure that you are careful not to use decimals. They gave us a decimal. So I went into NORI to see what do they want. They want that decimal. So if it's a decimal they're giving you, know that it's okay to give a decimal back. At least that's the pattern I've seen. So right now that 6.25 or the 6.25 radical 3 is what will be accepted in the account. So this was again a question right off of your NORI, so that's why I wanted to make sure I addressed that. The very next question, same idea. In fact, both problems we gave the hypotenuse instead of a decimal, they gave it to us as a fraction. So, same steps, opposite the 30-degree angle is A, opposite the 60-degree angle is A radical 3, opposite the 90-degree angle is 2A. We're going to circle the side with the formula and the given value, and we set those equal to each other. So 2A would equal 20 over 3. Now we're going to divide both sides by 2. And if you don't remember, that's like saying we are going to multiply by the reciprocal. Now, again, I'm going to show it to you here. And when I multiply a fraction divided by a fraction, if we multiply by the reciprocal, it's like saying 1/2. And hopefully we recognize that the 2 and the 20 will cancel to 10 and 1. If you don't, just keep in mind, in my calculator, I could do 20 ABC3 divided by 2. And okay, it gives me 3 1/3, but for what we're going to do, we're going to change that. Miss J taught me this, because again, I didn't know until just recently. We're going to change that back to an improper fraction. And there's our 10/3 again. So you could do that all in your calculator and find out, just like we did here, that A is 10 over 3. They gave it to us as an improper fraction, so most likely they're going to want to look at it as an improper fraction. So on this side, we know that this side would have to be 10/3. And on this side, we would take that 10 over 3 and multiply it by radical 3. It would be written 10 radical 3 over 3. So make sure when we are labeling our sides that we're plugging it into, and I again did this one in NORI to make sure, and that's exactly what they were looking for, this fraction. So we'd have to input that in the numerator, and then in the denominator put our 3. Hi, Siona. I love that you join me every day. So the first 2 questions, we're going to zoom out here for a moment. All 4, in fact, all of them that I'm doing today are again from your NORI assignment, so that it gives you an opportunity to kind of look at our steps. And for every problem, you can see in green, I write my formula. In blue, I do all of the plugging in, and then our final answers I have consistently done in red, so that you can kind of see how that's worked out. All right, so just a few more. Ultimately, I think by the time I'm done with all of this, I've done 8. I'll have done 8 today, and I did 2 on Friday. If you access the notes or the video, I did 2 on Friday. So that's 10 questions I've completed out of your NORI assignment. So just keep that in mind. All right. Again, we want to solve for our missing sides. So opposite the 30 is A. Opposite the 60, notice how we're down here now, is A radical 3. And opposite our 90 is 2A. So our first step was figure out which formula to use. Second step, write the formula around the picture, around the triangle. Third step, find the side that has the formula and the given value and set them equal to each other. So we're going to take 2a and set it equal to radical 15. We're going to divide away the 2, and we end up with a equals radical 15 over 2. So that means on the side with a, so that's over here with x, we have radical 15 over 2. And that's it. Done. Over here, we're going to plug in radical 15 over 2, but we still have to multiply it by radical 3. And that radical 3 is over an invisible 1. So we've got some work now. We have to simplify. So this is going to come out to be radical 45 over 2. We need to simplify. I'm hoping that we can see in the numerator that the square root of 45 is 9 times 5, and then everything's still over 2. That hasn't changed. So when we write our final answer for this side, it ends up being 3 radical 5 over 2. So y is 3 radical 5 over 2. And again, we just plugged it back in, but we had to make sure that we simplified. This guy and this guy were the answers that were requested. So make sure you see that it's a radical in a fraction. More radical. Again, figure this was a good way also to get us to review simplifying radicals. Opposite our 30 is a. That means this guy's got to be 60. So opposite our 60-degree angle is a radical 3. Opposite our 90-degree angle is 2a. We're going to circle the side that has the value and the formula, and we set them equal to each other. And it's a radical, but doesn't really matter. It's still a number times a variable, so we have to divide away. And our rules for division of radicals does say that these two can be kept together. So what we need to remember is that's like saying 6 divided by 3. Well, 6 divided by 3 is radical 2. So when we do get our final answer here for A, we end up with 6 radical 2. And that's because that 6 came straight down, and these two simplified to radical 2. So everywhere I see an X, or excuse me, everywhere I see an A, we're going to go ahead and plug in 6 radical 2. And that's our answer for X. Over here, we're going to plug in 6 radical 2. And we end up with now y equals 12 radical 2. Because again, our like terms, we're able to multiply them together. So at least me, this guy was a little bit easier, but I had to remember that rule in order to make that happen. All right, last two. We have our 30, 60, 90. And we're going to start with our steps. Opposite our 30 is A, opposite our 60 is a radical 3, opposite our 90 is 2a. We circled a side that has the value and the formula, and we set them equal to each other. So a radical 3 equals 7. Divide the number away from a, so we're going to divide both sides by radical 3. And we end up with a equals 7 over radical 3. Now, this again is review. We did a couple of these the other day. We have to remember that we can't leave the radical in the denominator, so we have to remember to rationalize. And that means get that radical out of the denominator. Easiest way to make a perfect square, multiply by itself. And again, if we see this pattern, we'll notice that the radical is now up on top. Our perfect square appears, but we end up with the radical on top and just the radicand underneath. So we just found out a was 7 radical 3 over 3. So that means this side would be 7 radical 3 over 3. And this side would be 2 times 7 radical 3 over 3, which would make this 14 radical 3 over 3. So what I wanted to do with this one is to remind us how to rationalize if it doesn't divide nicely. Last but not least, the 8th no-re question directly off of your assignment. We have, oops, wrong marker, our 60-degree angle. So opposite our 30 is a, opposite our 60 is a radical 3, opposite our 90 is 2a. We're going to circle the side that has the formula and the value, and we set them equal to each other. And just like before, we are going to divide away the radical 3. So we are left with a equals 22 over radical 3, and we have to rationalize again. So that means multiply top and bottom by that radical, and we end up with 22 radical 3 over the square root of 9. And just like the pattern from before, we end up with a equals 22 radical 3 over 3. Notice the radical jumped on top and just the number inside, the radicand, on the bottom. So that means this side is 22 radical 3 over 3. And this side would be 2 times 22 radical 3 over 3. And it's not going to cancel because they're not the same. So we end up with 44 radical 3 over 3. And we're done. So with the questions that I did today, I wanted to make sure that you had enough examples so that when you are working on your no reassignments, you can see that I have all of these now worked out. I will take screenshots of them. I will upload them to Google Classroom. On Wednesday, we are going to just run a question and answer session so that you can kind of get caught up now that your 9-4 no reassignment is should be worked on, and same thing for Friday. So if you have any questions, please let me know. Email me screenshots and I will get them back to you. And then we'll talk again on Wednesday. Thank you for those of you that showed. Siona as well, thank you always. And I will talk to you guys on Wednesday.